This is Mrs. Zappia with Lesson 4 in Module 3, Writing Products as Sums and Sums as Products. Student outcomes for this lesson. Students use an area model to write products as sums and sums as products. Students use the fact that the opposite of a number is the same as multiplying by -1 to write the opposite of a sum in standard form. Students recognize that rewriting an expression in a different form can shed light on the problem and how the quantities in it are related. Pause the video and write the essential question. How do you distribute a negative, and how do you write a sum as a product? For problems A through D, in example 1, use the distributive property to write each product as a sum. Pause the video and then resume it to check your work. 2x plus 10, 3x plus 12, 6x plus 6, and 7x minus 21. Notice that in these problems, there is a common factor. In the first row, the common factor between 2 and 10 is 2. In the second row, the common factor between 3 and 12 is 3. In the third row, the common factor between 6 and 6 is 6. And in the fourth row, the common factor between 7 and 21 is 7. We're going to use that concept in the next section, where we are going to write each sum as a product. So we are going to look for the greatest common factor between the two numbers. Here we have 5x and 30. So we want the common factor in the numerical portion, 5 and 30. They have a common factor of 5. 5 times 1 and 5 times 6. The common factor is what we will be factoring out. So we're going to divide each term by 5. 5 goes into 5x, 1x time. Think of it as what would you need to multiply to get 5x. So 5 times 1x would equal 5x, and 5 times 6 would equal 30. Now, when the coefficient is 1, we generally keep it invisible because 1 times x is x, and that would be in simplest form. So factoring out the 5, and then this would be the other factor, 1x plus 6. So to write that sum as a product, it would be 5 times the quantity, x plus 6. You can also double check to make sure that's right by multiplying it back out. 5 times x is 5x, and 5 times 6 is 30. In the next row, the common factor for 8 and 8 is 8. So we will be dividing by 8. 8 into 8x plus 8. So you can ask yourself, what would you have to multiply by to get the product? 8 times x would equal 8x, and 8 times 1 would equal 8. So the factors are 8 and x plus 1. 8 times the quantity, x plus 1, is equivalent to 8x plus 8. The problems in the left-hand column, these are the products, and on the right, these are sums of two terms. For the next problem, we want a common factor between 3 and 12. 12 can be written as 3 times 4, so the common factor is 3. Divide by 3. The expression is 3x minus 12. Again, ask yourself, what would you need to multiply to get the term? 3 times x equals 3x, and 3 times 4 equals 12. So the factors are 3 and x minus 4, because of the minus in the original expression. So writing 3x minus 12 as a product is 3 times the quantity, x minus 4. Compare the product and the sum and make sure that makes sense. 3 times x is the 3x, and 3 times minus 4 is minus 12. In the last row, 15x plus 20. We want a common factor between 15 and 20. "15 is 3 times 5, and although 20 can also be divisible by 2 and 4 and 10, it needs to be a factor that is in both lists. And so 20 can also be written using 5. 5 times 4. So 5 is the greatest common factor. We're going to divide by 5. 5 goes into 15x 3x times. 5 times 3x is 15x. 5 goes into 20 4 times. 5 times 4 is 20. And this was a plus, so our two factors are 5 and 3x plus 4. 5 times the quantity, 3x plus 4. You can check to make sure that's right by multiplying it back out. 5 times 3x is 15x. 5 times 4 is 20. And we have a plus sign on the left and a plus sign on the right. So again, the problems that are on the left side of the column, these are written as products because you're multiplying two factors. One of the factors is a number, the other factor is an expression. On the right side, we have the sum of two terms. In exercise 1, rewrite the expression as a product of two factors. So we are going to divide by the greatest common factor, and when it says write them as a product of two factors, remember that means in the form of A times the quantity B plus C. This is a sum, and we are going to write it as a product of two factors. The greatest common factor for 72 and 8. So start with the smallest number and see if it divides evenly into the larger number. And 8 does divide evenly into 72. So the greatest common factor is 8. So we are going to divide by 8. Inside the division house, write the expression 72t plus 8. When you divide, 8 goes into 72 9 times, and remember the variable. 8 times 9t is 72t, plus 8 times 1 is 8. 8 goes into 8 one time evenly. So our two factors are 8 and 9 plus 1, 9t plus 1. So writing this as a product of two factors, the first factor is 8, the second factor is an expression, 9t plus 1. You can always multiply it back out using the distributive property to check and make sure your answer is correct. Try the next problem. Pause the video, and when you're ready to resume it, to check your answer. The answer is 11 times the quantity 5a plus 1. In the last row, 36z plus 72. Now 36 is a factor of 72, so 36 times 2 is 72. 36 is our greatest common factor. There are other common factors, but you want to use the greatest common factor. We'll be dividing by 36. Inside the division house, write the expression 36z plus 72. Now divide. 36 goes into 36 one time, 1z. And 36 goes into 72 two times evenly, and bring up the plus sign. So when you multiply 1z plus 2 times 36, that will give you 36z plus 72. Our two factors are 36 and the expression. Now remember, when 1 is the coefficient, we keep it invisible and we just write z plus 2. Then if you're not sure if it's right, multiply it back out. 36 times z is 36z, and 36 times 2 is 72. So our answer is correct. For the next problem, we have subtraction. You solve this in the same way, where you divide out the greatest common factor. The factors of 15 are 3 and 5, as well as 1 and 15. I know that 144 is not divisible by 5 or 15, but it is divisible by 3. I know that because 144 is divisible by 12, and a number that's divisible by 12 will also be divisible by all of the factors of 12, and 3 is one of them. Then to figure out the other factor, you just do the division. 3 goes into 14 4 times with 2 left over. 3 goes into 24 8 times. And so that would be 3 times 48 is 144. So our common factor is 3. We'll divide by 3. In your division house, write the expression 144q minus 15. Divide by the greatest common factor, 3. 3 goes into 144 48 times. And 3 times 48q is 144q. Bring up the minus sign, and 3 goes into 15 5 times. 3 times 5 is 15. So our two factors are 3, and the second factor is the expression 48q minus 5. This is a sum. Even though it's a subtraction problem, it's still considered a sum because you could rewrite it as addition. And this is considered the product. When it says write each sum as a product, you are factoring out the greatest common factor. For our last problem, we have 3 and 3. So our greatest common factor is 3. Our expression 3r plus 3s is in the division house. 3 times r is 3r, and 3 times s is 3s. And remember the addition sign. So our two factors are 3 and r plus s. You can double check your answer. 3 times r is 3r, and 3 times s is 3s. Example 2. Let the variables x and y stand for positive integers. Let 2x, 12y, and 8 represent the area of the three regions in the array. So remember, if this is the area, then the length times the width would equal that number. Determine the length and the width of each rectangle if the width is the same for each rectangle. So here we want to figure out what number goes in the front here, and remember that it needs to be evenly divisible into 2, 12, and 8. If you start with the lowest number, that's going to help you find the answer faster. Factors of 2 are just 2 and 1. So if 2 is a common factor, then it is the greatest common factor. Although 12 and 8 have other factors like 4 or 6 or 3, it needs to be a factor of all three numbers. So 2 is our greatest common factor. Then 2 goes into 2 once, and then 2 times 1x, or just 2 times x, is 2x. So that would be the length and the width of the first rectangle. The length and the width of the second rectangle. 2 times what is 12y? 2 times 6y. So 2 is the width of the rectangle, and 6 is the length of the rectangle. And finally, 2 times what number is 8? 2 times 4. So the length of the rectangle is 4, and the width of the rectangle is 2. So the width of all of these rectangles is 2. That's the greatest common factor. Then the length going across the top is x, 6y, and 4. 2 times the quantity, x plus 6y plus 4, is equivalent to the area of the rectangle, which is 2x plus 12y plus 8. This is the area of the entire rectangle, and it is made up of the width times the length. Exercise 2. Write the product and sum of the expression using the represented in the rectangular array. The product and the sum. So let's just take a look at the problem that we just completed. The sum is the area that's inside the rectangle, and the product is the width times the length. So the sum for this one will be 24d plus 8e plus 6. And then the product, which is the length times the width, will be 2 times the quantity, 12D, plus 4E, plus 3. These are equivalent expressions. One of them is written as a product and the other is written as a sum. Factor 48J plus 60K plus 24 by finding the greatest common factor of the terms. Pause the video, solve this problem, and then resume the video to check your work. The greatest common factor for 48, 60, and 24 is 12. Notice that I wrote a couple of different multiplication problems for each one, and I noticed that 8 is not a factor of 60, so I could not use 8 as the greatest common factor. Then divide by the greatest common factor. 12 goes into 48 4 times. 12 times 4j is 48j. 12 times 5k is 60k, and 12 times 2 is 24. So the answer in factored form is 12 times the quantity, 4j, plus 5k, plus 2. For each expression, write each sum as a product of two factors. Emphasize the importance of the distributive property. Use various equivalent expressions to justify equivalency. So remember the sum is written in the form of AB plus AC, and the product is A times the quantity, B plus C. We're going to do the second row, starting with problem D. X times 3 plus X times 5. Understand that multiplication is repeated addition, and if you want X times 3, that means you want X plus X plus X. That means 3 times X. And 5 times 3 is 5 plus 5 plus 5. So really, this problem is equivalent to 3 times x plus 3 times 5. Now you can see the common factor. The common factor is 3. So we'll pull out 3, and we have left x plus 5. Now let's double check to make sure that's right. 3 times x is 3 times x, and 3 times 5 is 3 times 5. Now let's make sure that we've answered the question. It says to write each sum as a product of two factors. So our first factor is 3, and our second factor is x plus 5. Problem E. So we have x plus 5, and x plus 5, and it says to write it as a product. Well, we have repeated addition 3 times. So this would be 3 times the quantity, x plus 5. And look at the similarity between the last problem. Here we have the 3 x's, the common terms collected, and the 3 5's together. Here we have x plus 5, and x plus 5. They're equivalent expressions. In problem F, now this one's a little bit more challenging because it has addition, and it has addition, and it has multiplication. And remember that when you have a mixture of multiplication and addition, you cannot use any order, any grouping. Only if it's all addition or all multiplication. So let's simplify this to eliminate the multiplication. 5 times 2 is 10. Bring down the rest of the problem. 2x plus 5 plus x plus 10. Since it is all addition now, I could eliminate these parentheses if I would like to. Using any order, any grouping, I'm going to reorganize this so that my like terms are collected. So I'm going to put the 2x plus x. Then I'm going to put my constants at the end of the problem, 5 plus 10. Collect your like terms. 2x plus 1x is 3x, and 5 plus 10 is 15. And these terms cannot be combined because they are unlike terms. Now, this is written as a sum, and we need to write it as a product. So we want to factor out the greatest common factor. 3 and 15 have a common factor of 3. 3x plus 15. Factor out the 3. 3 times x is 3x, and 3 times 5 is 15. So the two factors are 3 and the quantity x plus 5. Writing that as a product is 3 times the quantity x plus 5. Again, notice that we have 3 equivalent expressions and 3 more equivalent expressions. Altogether, all 6 of these are equivalent. Example 3. A new miniature golf and arcade opened in town. For convenient ordering, a play package is available to purchase. It includes 2 rounds of golf, 20 arcade tokens, and a $3 off the regular price. There is a group of 6 friends purchasing this package. Let G represent the cost of golf. Let T represent the cost of a token. Explain how each expression describes the situation in a different way. So there's a bit of missing information from this problem, so let's talk about that. The cost of the golfing, each person is going to golf for 2 rounds of golf. So that's going to be 2 times the cost of a round of golf. And they're going to purchase 20 arcade tokens. So that's 20 times the cost of a token. In addition to that, they're going to save $3. So that's going to reduce their price, so we subtract 3. That is the cost of one person going to the arcade and golf. But there are 6 people going, so we want to multiply this entire quantity by 6. Additionally, we could figure out the complete cost for the golf. There are 6 people golfing, 2 games each, so that would be 12 golf games. There are 6 people getting 20 tokens, so that's going to be 120 tokens. And there are 6 people saving $3, so they're going to save $18. Now think about the operations. Between the golf and the tokens, that is going to increase the cost, so that is added together. But the $18 is going to decrease the cost, so that is the subtraction. So now we have 2 expressions. Now, so when it says explain how each expression describes the situation in a different way. So the problem on the right, this is the total cost for 12 rounds of golf, 120 tokens minus the $18. Then this one, inside the parentheses, this is the cost for one person, and then you're multiplying it by 6 people. So it's going to cost the same amount, it's just how do you want to figure out the cost. In this case, it's written as a product of 6 people times the cost. And on the right side, it is just written as a sum of each individual part, the golf, the tokens, and the discount. Example 4. What is the opposite of 2? Remember that another name for opposite is the additive inverse. And that is, what number needs to be added in order to get a sum of 0? And that would be -2. What are the 2 mathematical expressions that represent the opposite of the quantity 2a plus 3b? Our 2 mathematical expressions, one of them would be the opposite of the quantity 2a plus 3b. And then the other one, if you want the opposite of that quantity, that means you want the opposite of each term. So the opposite of 2a is -2a. And the opposite of adding 3b is subtracting 3b. So both of those are opposites, but they are written in different ways. They are equivalent to each other. Use the distributive property to rewrite -1 times the quantity 2a plus 3b as an equivalent expression. -1 times the quantity 2a plus 3b. Drawing your arrows can help you to distribute the factor to both terms inside the parentheses. So we have -1 times the first quantity plus -1 times the second quantity. The first quantity is 2a, the second quantity is 3b. -1 times 2a is -2a plus -1 times 3b is -3b. Generally, when you have 2 signs next to each other, like in this problem, you will rewrite adding the opposite as subtraction. That is the definition of subtraction, adding the opposite. So we write this as 2a minus 3b. These are equivalent expressions. Using the rule of subtraction, we have rewritten it. Notice negative 2a minus 3b and negative 2a minus 3b. So here, when you multiply by negative 1, that is the same thing as taking the opposite of a sum. Where have you heard that before? The opposite of a sum. That is the same thing as multiplying by negative 1. Exercise 4. What is the opposite of the quantity negative 6v plus 1? So the opposite would be, putting a negative sign in front of it, negative 6v plus 1. That is the opposite. Using the distributive property, write an equivalent expression. So remember that when you take the opposite of something, that's the same as multiplying by negative 1. So we'll multiply the quantity negative 6v plus 1 times negative 1. Using your arrows can help you to remember to distribute the negative 1 to both the first and the second term in the parentheses. So we have negative 1 times the first term plus negative 1 times the second term. Negative 1 times the first term plus negative 1 times the second term. The first term is negative 6v, negative 6v. The second term is 1, and the operation is addition. So here a negative times a negative is a positive, and that gives us 6v plus a negative times a positive is a negative, negative 1. Now, because we have two signs in a row, let's rewrite adding the opposite as subtraction. And that answer will simply be 6v minus 1. Now compare that to the original expression, negative 6v plus 1. And we wanted the opposite of that. So the opposite of negative 6v is positive 6v. And the opposite of adding 1 is subtracting 1. Example 5. Rewrite 5a minus the quantity a minus 3b in standard form. Justify each step applying the rules for subtracting and the distributive property. First, let's recopy the problem. 5a minus the quantity a minus 3b. You'll want to start this problem by rewriting subtraction as addition. Remember, when you rewrite subtraction, that you are adding the inverse. And that is simply the rule of subtraction. So we are going to change this subtraction to adding the opposite, and we are going to change this subtraction to adding the opposite. So bring down your 5a, change your subtraction to adding, and then we want the opposite. So we need the negative sign here. And let's use parentheses to show that. And we need the opposite of this whole parentheses, this whole term, a minus 3b. Let's do that one more time. Subtraction means add the opposite. So I want to add the opposite of a minus 3b. So I'm putting the opposite in front of a minus 3b. Additionally, I want to change this subtraction to adding the opposite. So that will be adding, and then the opposite of 3b is negative 3b. I know that looks a little confusing. It takes a little practice, but you'll get it. Now let's clarify this. 5a plus. And this negative, when we want the opposite of something, we just learned up here that you can multiply that by negative 1 to get the opposite. So let's replace that negative sign with a negative 1. Bring down the rest of the parentheses, a plus negative 3b. Now we can distribute the negative 1 to both terms inside the parentheses. Draw an arrow so that you remember to distribute the negative 1 to both terms. Bring down the 5a. Negative 1 times a is negative a. Plus negative 1 times negative 3 is a positive 3. So that's 3b. Now we're going to rewrite and combine like terms. 5a plus negative a is 4a plus 3b. These terms cannot be combined because they are unlike. So our answer in simplest form or standard form is 4a plus 3b. Now let's compare that to the original problem. We started with 5a. When you want to subtract parentheses, that means you need to subtract both terms. So subtracting a, that gave us the 4a, and subtracting a negative is adding a positive. So our answer is correct. And it said justify each step applying the rules. So the first step that we did was to rewrite subtraction, adding the inverse, and that is simply the rule of subtraction. Then we wrote the opposite of a number is the same as multiplying by negative 1. That's right here. The opposite of a number is the same as multiplying by negative 1. The opposite of a number is the same as multiplying by negative 1. Then we distributed the negative 1. The last thing that we did was to combine like terms. And that is not a property, that was just a math problem that we did. Exercise 5. Expand each expression and collect like terms. Copy the problem. Negative 3 times the quantity, 2p minus 3q. I'd like you to pause the video and try this problem on your own, and then resume it to check your answer. Check your answer, make any corrections, and continue to the next problem. Negative a minus the quantity a minus b. The first thing we want to do is to rewrite our subtraction as addition. Recopy the problem. Negative a minus the quantity a minus b. First, change subtraction using the rule of subtraction to adding the opposite. So we start out with negative a. We're going to change a negative to adding the opposite. We're going to add the opposite. Now we want the opposite of what's inside the parentheses. Inside the parentheses is a minus b. Now let's replace that negative 1 as replace the negative as multiplying by negative 1. So here's the negative 1 that we're going to multiply. And bring down the rest of the problem. The negative a, and then inside the parentheses a minus b. And parentheses around that entire part. Next, multiply or distribute the negative 1 times both terms inside the parentheses. So the negative 1 times a is negative a, and the negative 1 times b is positive b, because a negative times a negative is a positive. So that's plus b. Now, bring down the plus sign and the negative a. Now we have a negative a plus a negative a, and that gives us a negative 2a plus b. Now let's go back to the original problem and compare that. Here you want to subtract the quantity a minus b, and that means you want to subtract a and you want to subtract the negative b. So subtracting the a minus a is minus 2a, and minus a negative is plus a positive. So our answer is correct. In summary, in writing products as sum, what is happening when you take the opposite of a term or a factor? The term or the factor is being multiplied by negative 1. When using the distributive property, every term inside the parentheses is multiplied by negative 1. To write a product as a sum, use the distributive property. To write a sum as a product, divide by the greatest common factor. In this case, A is the greatest common factor.